This is an interesting problem. And the reason why it's an interesting problem is because like, where do I begin? What exactly do I even do? How do I divide something and then divide it again? And then the negative exponents, it can just confuse a lot of students. And it'll confuse a lot of students so much that they will just give up. They won't even try it. So what I want to do in this video is give you some ways to approach a problem, even when you start to get confused, to kind of slow down, recollect your thoughts and say, all right, what is it I know? And what is it I can do about that problem? So let's forget about the negative exponents for a second. Let's just go ahead and do the threes. So if I did 3 divided by 3 divided by 3, and you might think, well, 3 divided by 3 is equal to 1, so that's the final answer. Maybe, I don't know. You keep on dividing by 3s, maybe it's 1/3. I don't know. But what I want to do is think about this. There's another way we can write division, right? 3 divided by 3 divided by 3 can also be written as 3 divided by 3 divided by 3. And then we know from our rules of exponents, right? We always work from left to right. That's critically important, especially for whenever we're dealing with division as well as subtraction. So let's just work from left to right. So 3 divided by 3 is going to be a 1. And then 1 divided by 3 is just going to be a 1/3, okay? So what do we do when we have these negative exponents? Or what can we really do in this case to kind of think about this? Well, remember, just whenever you have x to the negative n, that is going to equal 1 over x to the n. So you can put it in the reciprocal therefore to use the opposite sign for your power. And the same thing works here. If I have 1 over x to the negative n, I can now go ahead and put that in the numerator with the positive power. So what I'm going to do for this problem is I'm just going to go ahead and rewrite it as a division problem. I'm simply just going to state 3 to the negative second power divided by 3 to the negative third power divided by 3 to the negative fourth. And now what I'm going to do is I'm going to say, well, I don't want to deal with negative exponents. Like, who wants to deal with negative exponents? Let's go ahead and rewrite these as fractions. And you might say, I hate fractions, but trust me, it's going to make your math a lot easier. So now what I'm going to do is say, all right, well, this is going to be 1 over a3 squared divided by 1 over a3 cubed divided by a 1 over a3 to the fourth power. And hopefully you know your powers and you represent, this is just representing repeated multiplication. So we can do this a little bit again. You probably could have skipped that step, but let's go ahead and do the work in our head. 3 squared is going to be 9. And then if you were to multiply by 3, that'd be a 27. So 27. And then 3 to the fourth power, that's going to be multiplying by 3 one more time. So 27 times 3 is going to be a 84. So divided by a 1 over, no, not 84, 27, 54, that's going to be an 81. Now, the next thing we need to remember is, well, how do we divide fractions? Well, dividing fractions is the same thing as multiplying by the reciprocal, okay? So to multiply by the reciprocal, right, all we need simply do is just rewrite this as 27 over 1 and change it to a multiplication. So now I can say 1 over 9 times a 27 over 1. And we'll still have the dividing of 1 over an 81. We'll get to that in a second. So let's multiply this through. Well, technically you just multiply straight across, right? When you're multiplying fractions, multiply straight across. 1 times 27 is 27, 9 times 1 is going to be 9, but 9 divides into 27, how many times, how many times, how many times? 3 times. So 27 divided by 9 is going to be a 3 divided by a 1 over an 81. Now I can rewrite that as multiplication, right? So that's going to be 3 times an 81. And I think this is where I was getting that 3 earlier before, because 3 times 81 is going to be a 243. That is how you find the answer to a problem like this.